Welcome to our online class. Today we'll talk on testing the overall significance of the sample regression. Let us consider the following k-variable regression model. yi is equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus dot 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 plus beta k xki plus ui. Our null hypothesis is beta 2 is equal to beta 3 equal to dot 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 equal to beta k equal to 0. This null hypothesis states that all the partial regression coefficients of the multiple regression model are simultaneously or jointly equal to 0. Our alternative hypothesis is not all slope coefficients are simultaneously 0. A test of such a hypothesis is called a test of the overall significance of the observed or estimated regression line, that is, whether y is linearly related to the set of explanatory variables. However, we cannot perform the test of the joint hypothesis by testing the significance of the estimated partial regression coefficient individually. That is, we cannot use the usual t-test to test the joint hypothesis that the true partial slope coefficients are 0 simultaneously. So let us consider the k-variable regression model as discussed earlier. Under the assumptions of normal distribution for ui and the null hypothesis beta 2 equal to beta 3 equal to dot 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 equal to beta k equal to 0, the variable f is equal to ESS explained sum of square divided by k minus 1 divided by RSS residual sum of square divided by n minus k. F is distributed as the F distribution with k minus 1 numerator degrees of freedom and n minus k denominator degrees of freedom, where k is the number of parameters to be estimated including the intercept and n is the number of observation or sample size of the regression model. That is, F is distributed as F distribution with alpha level of significance, k minus 1 numerator degrees of freedom and n minus k denominator degrees of freedom. So there is a relationship between f and r square. For the k variable regression model, the relationship is given as follows: f is equal to r square divided by k minus 1 divided by 1 minus r square divided by n minus k. Here r square is the coefficient of determination of the multiple regression model. So this ratio, this f value will give us the calculated f value or computed f value. That is, using this formula we have to compute the f value and then we have to compare it with the critical f value obtained from the f distribution. If the f computed f value exceeds the critical f value at the Sujan level of significance, then we may reject the null hypothesis, otherwise accept the null hypothesis. So let us consider an example. In this example, CM refers to child mortality, PGNP stands for per capita GNP, and FLR means female literacy rate. In this regression result, 263.6416 represents the constant term and minus 0.0056 represents the coefficient of per capita GNP, minus 2.2316 represents the slope coefficient of female literacy rate. AC represents standard error, T represents T ratio, and this represents p-value. R square is called the coefficient of determination. Here the value is 0.7077 and this term is called adjusted R square. So now we want to test the hypothesis that the overall significance of the estimated multiple regression model, that is finding out if all the partial regression coefficients are simultaneously equal to 0. So let us formulate the model in general form as follows. Cmi equal to beta 1 plus beta 2 pgnpi plus beta 3 flri plus ui. Therefore, our null hypothesis can be written as follows. Beta 2 is equal to beta 3 is equal to 0. This null hypothesis states that the two partial regression coefficients of the above multiple regression model are jointly or simultaneously equal to 0. As discussed, this kind of test is called the overall significance of the observed or estimated regression line. That is, in this case, where the child mortality is linearly related to both PGNP and FLR. And to test this joint hypothesis, we cannot use the usual t-test, rather we have to use the joint distribution. Under the assumptions of normal distribution for ui and the null hypothesis beta 2 is equal to beta 3 is equal to 0, the variable f is equal to ESS divided by degrees of freedom divided by RSS divided by degrees of freedom. In our case, k equal to 3, and so the numerator degrees of freedom becomes 2 and the denominator's degrees of freedom becomes n minus 3. So in the above estimated multiple regression model, the ESS and RSS values are not given, and so we cannot use the above F formula in terms of ESS and RSS. And we know there is a relationship between F and R squared, and that is expressed as follows. F is equal to R squared divided by K minus 1, 1 minus R squared divided by N minus K. And in our case, this formula uh, this formula can be transformed into this expression: r squared divided by 2 divided by 1 minus r squared divided by n minus 3, as we have k is equal to 3. So in the given model, the r square value is given as 0.7077. Now substituting the value of r square as obtained from the estimated multiple regression will get f is equal to 0.7077 divided by 2 divided by 1 minus 0.7077 divided by 64 minus 3. After simplification, we'll get the f value equal to 73.8726. Now to get the critical F value, let's visit the F distribution table, and we will see that for two numerator degrees of freedom and 60 denominators degrees of freedom, for 5% level of significance, the critical F value is 3.15, whereas for 1% level of significance, the critical F value is 4.98. So we can see that the computed F value exceeds the critical F value, that is 73.87 to 6 is greater than 3.15. Since the calculated F value exceeds the critical F value at the chosen level of significance 5% here, we may reject our null hypothesis that the two partial regression coefficients of the multiple regression model are jointly or simultaneously equal to 0. So there are 6 steps of testing a joint hypothesis. First, we have to write the general form of the estimated multiple regression model and formulate the hypothesis. Second, we have to choose the F formula based on available information, that is F formula in terms of ESS and RSS, or F formula in terms of R square. Third, we have to compute F value by substituting the obtained relevant values in the F formula. Fourth, we have to choose the appropriate level of significance and obtain the critical F value from F distribution table. Fifth, we have to compare the computed F value and the critical F value. Sixth, we have to make our decision, that is, we may reject the null hypothesis if the calculated or computed F value exceeds the critical F value at the given level of significance, otherwise accept the null hypothesis. So here is example 2, which you have to do it yourself. In this example, you can use the formula in terms of ESS and RSS rather than the formula of F in terms of R square. Thank you very much.